Hello, everyone. Welcome to this session of optimizing cost and user value through routing agent. I'm Aditya. I'm from Meta. I'm a machine learning engineer working on different ranking recommendations and different problem spaces within Meta. Before I get started, I want to get a sense of how many of the people here in their organization or product are using only single LLM API provider. Just one. One, not a lot people. Okay, couple of them there. Uh, okay. And how many of you think would be great if you can have a black box which can figure out, I don't care about which API I'm using, which LLM I'm using. I just care about the user value, the what is the performance coming from that LLM, and what is the cost or the billing that is happening to me. How many of you think that would be great to have in your organization or product? Okay, great, awesome. Okay, so you are in the right room. So I hope by the end of this talk, we are going to talk a lot about technical details, but you will have a lot of takeaway with respect to why you would want to diversify your LLM APIs and how you can do that technically and like through Databricks platform. So the high-level talk would be on the four sections. First, we will learn about what are the different LLM components, which is related to the cost, and how does different LLM providers has a cost variability. We will dive a little bit into the Llama and the open source system. The second part of the talk would be understanding what are the different goals and user value and categories and technical high-level details of LLM routing. And in the third part, we will take a technical deep dive. We will understand the core components, what are the feature, data, training loss, and how you can do online and offline evaluation. How can you measure the cost and savings, and different aspect related to the cold start. For example, if there is a new model come in, or if there is a new prompt or a query time come in, how do you kind of like deal with those cases? And in the last section, we will be talking about how do we implement these part three about technical details using Databricks component. I believe most of the people here are very much familiar with that. So we'll go through how the routing and Databricks comes together. So the first section is LLM component. When we look at the LLMs, there are different component of the cost associated with it. The providers are charging you a particular dollar in and out for input and output token. That will be the premium and the most important cost. The bigger your input length is, the bigger output length is, the more cost it is to provider, the most cost it is to you. Embedding layer is another one where the embedding size and dimension can change the cost from the provider's perspective. Third would be a parameter count. The bigger and the more complex and the larger number of transformer layers on the model it is, the more flops it is needed. The more flops it is needed, the higher the cost would be. That's why we are seeing a huge variability that, okay, we have 8B models and 500B models having a huge difference in the cost. Then there are other components like retrieval augmented generation and other minor costs related to the embeddings, loggings and all, which is pretty minor. So this is a chart which is showing that how drastically the variation happen in the cost. If on the one side we have some APIs which are charging all the way to $75, and the other side we have 0.15 through the open source model, and these are the models which are very cost effective, and a little bit of comparison of like the leftmost and the rightmost is like 500 times. That's huge. Even if you are able to divert like 10% of your query to this, like the old model, like or the smaller model or some X percentage, your cost will be multiplied by a fraction of what you are actually being currently paying. So we will be talking here the Llama ecosystem. This is an open source from Meta. I think we all are aware of this thing, and it has series like 3 and 4 series. It is a collection of open source model to provide stability, to tailor to a particular AI needs, since it is open source, provide higher transparency, security, and also the greater control to individual organization as compared to a closed source model. And just because you are using an open source and a low cost model doesn't mean that you do not have a competitive edge. These are the models here that you can deploy anywhere, like on cloud, on premise, in your like box device, GPUs, anywhere you want. It provides a higher data security and privacy control. It creates an ecosystem within your organization because for example, for some use cases, you might need just 8B model. For other one, you need like a high-end reasoning models. Because it is open source, the weights are available out. That means you can do a lot of customization over to the model and change the architectures and like do different kind of experimentation with it. And we believe the future of the LLMs are open source, and we are heavily investing on this side. Um, this slide shows like what are the different features and performance of different Llama models we have. We have a lightweight, ultra-fast model, then the reasoning models, the model which can understand like text and multimedia in a better way. And there are also models which are 1B, 3B, which are on-device model if you want to use like some on-device and have the privacy and other aspect preserved. On the rightmost side, we have the latest models of Llama 4.0, which is multimodal. It has a superior text and visual intelligence. It is based on MOE architecture, and it supports like 12 languages, and it has a context window of 10 million, which is huge. You can put a book to LLM and ask any questions out of it. So based on like different characteristics, you can figure out what is the right accuracy you need, what is the latency of the model that you need, and what is the cost associated with model, and you can make a smart decision. So this is, we are talking only within Llama ecosystem. Like this is the variability you have. Now let's come to the second section where we are talking about the goal of the routing, what are advantages and categories. So the primary goal for routing of your LLM router is that you want to optimize cost, but you do not want to compromise on the user quality. You still want to maintain it. You want to make sure that the users are still like being good, but the cost is lower. Why do we need routing in the first place? First and the most important is it is cost effective. Like we have seen that in the previous slide, it's a fraction of a cost Llama 3 as compared to the other closed source model. It can lead to a performance optimization because there is no one model fits all the cases. There are models which are good for coding, reasonings, mathematical operation, and those kind of things. So by intelligently rerouting, you are actually finding the best model for the given prompt and a query. There is no vendor lock-in because router will take care if the new model come in, there is a new company which is open sourcing or like putting out the model, it will automatically kind of like take that into consideration and make sure that anything which is there out there is available there, and there is no vendor lock-in happening in this case. Enhance scalability, higher user satisfaction because now you have a diversity and a pool of model to answer from. Reliability and failover, if one model fails, there is a policy issue or any kind of things, you are still like good with your infrastructure stack and you are still rerouting in the right way. And then a quick rollout of the models. Coming to the user satisfaction, what do we care about? Like when you are interacting with LLMs, when your customers are interacting with LLMs, like what are the factors which consider in the user satisfaction? One is like the complete and a concise answer. What is the cost associated with it? If you have two kind of, for example, in a B2C, if one is charging $100, other one is charging $20 a month, and they're providing the same quality, it's a no-brainer to go with a low-cost one. Accuracy and factually correct, how relevant your answer is to the question asked, how clear it is, and whether it is able to safeguard and have guardrails related to toxic and other kind of like issues that happens and in a wider ecosystem. And of course, the latency where you want to make sure like the answer is coming quickly, user is not waiting for seconds to get the answer. Now, coming to the categories of LLM routing, we have first one, which is the static routing, which is the like the low complexity, where you are actually manually putting if else and different kind of condition to say that okay, it belongs to coding, and I know that there is a particular coding model which is good. Like let me reroute it to do. So these are the predefined rules. The second is more sophisticated, which is a classifier-based routing, where you are understanding the prompt pretty well, and you are classifying that prompt based on some model classification. And then there is a semantic routing within it, which we will talk, where we understand the similarity of the prompt, and we see that what are the prompts which are similar, and what are the responses in the past which has been given by this LLM router, and we directly take the top voted one. And there are LLM based methods like reward model, like putting the prompt directly within LLM to find what is the best routing model to go with. So, okay, static routing. So, for example, if the question is like, what is the weather in SF? You really don't need to call LLM and do a lot of complex processing, reasoning, and all those things. We know that this is a direct function call. So, you don't even need to pay for the input output token. You just need to make an API call and you will get the weather and just put it in the format. Similar to that, if you have in your organizations a fine tuning model, basically you are understanding, okay, this query belongs to a particular aspect and there are already models that I've tuned within my organization, and it's a no-brainer to read out the query to that. That's where the fine-tuned model would give the highest performance, and it's a very static and a simple routing. Similar to that, we can have a keyword-based extraction that, okay, if it is a coding-related thing, you understand there are certain kind of like code aspects which are there in the query. That means you know which model to reroute it to for the highest and the optimal performance. And then you can have different custom-based rules like length and finding different attributes within your prompt and say that, okay, this belongs to reasoning. Let me find the reasoning model rather than just calling the default model. So in the ML-based classifier routing, how do we train it? We can take a existing the board-based model for classification, where the input is the prompt embedding, then output is the model classification. So if you have 5 models of pool that you want to like have the rerouter to have intelligence on, that will be your output node, and input would be prompt embedding and different features. This could be a binary, that means a single class or a multi-class classification. That means your model can be trained in a way in which your in-house preference data set can have multiple output which are all good, and then you pick up the lowest cost based on the threshold that you have picked in. For example, if the threshold is 0.8 and there are 3 models coming in which are passing that for an input prompt, you pick the lowest cost model because everything is above your threshold, so you are not compromising on the user quality. On the semantic routing, this is where you are actually getting into the embedding space, understanding like how do we read out the query based on the embedding of the input query and what is already out there. So in the offline processing, you would have a predefined data set with a human labeling, and then what is the corresponding best LLM for those queries already out there. And then we will generate the embedding of this, put it into a vector database using some um, similarity library, and then whenever the new prompt come in, we will generate the embedding of this, find the nearby prompt, and then find the model which is selected for those similar prompts. So this is more like you are understanding and from the past what is the semantic routing similarity, and based on that you are updating the uh, response. LLM as a router is another one where the LLM is trained to predict a particular scalar score, let's say between 0 and 1, which indicates the quality of a response. And this is trained on a human preference data set or LLM as a judge or based on certain rubrics like helpfulness, clarity, harmlessness. And in this framework, a cheap model can be first given to your input query. LLM reward will give a reward, and if it is lower than threshold, that means only then you need to give it to a costly model, otherwise you are good on this part. And this could be deployed in a hybrid environment. That means you can have a semantic or a rule-based query along with this to merge and make a custom output. Another way would be that like you can directly put a prompt to an LLM. It may not be the optimal, but still it's good to know that this is another way to do it. Where all the information related to LLMs, for example, what is the benchmark performance, what is the cost, input output API cost, and other things out there, what are the specialty of those LLMs providers. You put it in a database, and then like given this standard prompt that okay, this is the information extracted from the RAG or your external databases, and then appending it the user query to that prompt. So that means you are directly asking LLM that okay, please provide me what is the best LLM to read out this to. And in this, we can add like few short examples of something that has been done in the past or some of the examples through which LLM can improve your performance by in-context learning. And of course, like there is a way to do the output formatting if you want to have a JSON object or some other way to see like whatever is the specific use case you have for this. Going to the technical details, the core component of the routers would be the features. These are the features related to the prompt, whether the prompt, like what category of the prompt it is, whether it's a complex prompt, reasoning prompt, coding prompt, we don't know. User, what is the expertise of a user? For example, if there is a user who is a PhD in ML and there is a high school student who want to learn about machine learning, same query would have a different response based on the user expertise, right? So you understanding the user, what they have done in the past, like using that history would be helpful. Model is like complexity of the model, performance on the benchmark, cost, input, output. Yeah. On the model pool, basically all the candidates of the model that we want to consider for routing, and a router which is an intelligence black box system which can figure out this is the prompt and this is the best response configured, this is the best LLM to pick from everything. And then the training data, which is like how do we train this model, what we talked about with respect to the word-based classifier or semantic routing or anything category which we talked earlier. The training data would include the query, the response, the LLM cost, quality, and inhuman or some way to give a quality measure either through LLM as a judge. And of course, once you deploy these kind of systems, you want to understand the explicit and implicit user feedback and make sure that you are not degrading in the quality just by putting a router in the middle as compared to using only one LLM API. So some of the features for routing, from the prompt side, we would have a raw text, prompt length, embeddings, entities, or different keywords that you can think of. This is something which is custom, but like these are some of the basic features. From the user, you would want to know what exactly is the expertise of the user, what are the historical interaction that the user had, what are the session details, whatever you can take from the user as per your policies and other thing, and of course like the explicit and implicit feedback from the user. On the model feature size, we are talking about the input output token cost, which is the most important feature that we are optimizing for. Capability of the model, whether it's a reasoning, RAG, or like chain of thoughts, or a simple good for coding or something. Performance on the standard benchmark to understand like which, like if the query is similar to some benchmark, then which is the low cost model you can go with. Latency of the model, because this is also related to the user satisfaction, and any prior knowledge. Okay, so now to build your training or creating your custom router, the first thing you would need to collect the data, and the most best way to collect data for your specific use case would be to have in-house or take a third-party data where you are given a prompt, and for that prompt you are given the response from all the LLM pools, and there is a human rater which will say that, okay, from 0 to 1 on different rubrics, like what is the score for all of those prompts, and that's the training data that you would want to have for your router. And then there is the synthetic data, because it's not possible to humanly create a lot of data set and label all of them. So there is this concept of synthetic data generation, which is happening a lot in different companies and different organizations, where you generate through LLM, given the seed data, please generate similar prompts and outputs. And understanding the historical performance and getting the user's implicit and explicit signals from the user to understand like how well it is performing is an important aspect of this. Okay, so we talked about like the training data. This is more deep dive into a loss function, because you are creating your own classifier. The loss function would be a cross entropy lot for a single or a multi-class thing. For example, if we are talking about the board-based classifier to give a score to each model given a prompt, then we would be basically picking up a dynamic threshold or whatever we think is good for our cost, and during the inference time, we will pick the lowest scored model which are above threshold of that. And okay, so here we talked only about the quality. That's how we are training this model. But if you want to make the model output not just the quality, but some function of the cost, then you would be changing your loss function and putting a cost variable in there. And this, by this lambda, you can just like change the dimension from the very high preference to the cost and like little to quality to high quality and low cost efficiency kind of thing. So this will give a little bit of like flexibility for user to when they're training their own router to give more. Yeah. So how do we train the model? We have our data collections. We have all the features what we talked about. We have a pool of LLM. We have our responses from these LLM from in-house trainers. We know the score, and we already have the cost which is available statically from different providers. And the quality score could be human annotator in-house, it could be LLM as a judge, or whatever way you can have confidence on what you mean by quality on that side. Then based on this data set, this is all you need to train a model. You can do a supervised learning and training with loss function that you pick for. Um, yeah, and then also there is a way to fine tune a smaller model on this data set, which can be used as a router. Going into a little bit more advanced thing, which we will not go too much into detail, but like there could be a RL-based agent which can learn about these interactions with the environment, and it would have all the states that we need for RL. That is the state, which is a prompt feature. What is the action? Action is like choosing which LLM, and the reward is a function of cost and quality that you can dynamically define in this one. Okay, so once we have trained it, we have our data, we have loss function figured out, and we know how to do everything on the training side. How do we do the offline evaluation? So on the data set that you have already created, you will have a holdout which contains the ground truth based on your quality assessment, your inhuman, or however you want to design that quality aspect. That's very subjective. And then based on the router, like there is a routing decision based from a base model to like this pool of model depending on the prompt and other feature. And likewise in the offline evaluation, we can understand what is the router accuracy, what is the quality score, because we have the ground truths. And then once it is good enough, then we will go to the second stage, which is online A/B testing. So in the online A/B testing, we would have first set up two different buckets. Basically, we will split our traffic into two bucket A and B, knowing and basically just doing our homework that there is no underlying distribution change or variation in that. There is nothing statically significant. For example, if you put everyone into all the expert people who are doing like very reasoning query into one bucket, and all the naive people who are doing very basic mathematical or like the simple query into other bucket, that would create a significance problem in our experimentation. So no sample ratio mismatch, yeah. And then we can deploy different kind of routing strategies to different bucket to see which one is doing well. So by well, we mean we are going to collect different matrices. For example, API cost incurred in each of the buckets. What is the user satisfaction based on either implicit or explicit feedback? What is the rate of completion, like how many of the queries and the prompt or response are good? Engagement metrics of the user, which is how often the users are coming to your platform. They really like, this is a proxy matrix, whether they really like your chatbot or however you have deployed your LLM application. What is the observed latency and the error rates that you are getting, and the qualitative feedback from the users either through survey or some other way. Once we have set up the matrices, use standard statistical methods to understand and analyze basically how we are doing on this aspect, and iteratively improve on this using different routing logic, adding more feature, maybe having more models, and deploy new experimentation, and quantitatively understand like how we can improve once the router is already launched on that side. How do we measure the cost saving? This is a very simple way of doing it. There are more complicated ways also. So in the first bucket, you already have like a predefined API or the model that you're using where the cost for all the LLM calls is same. Now in this one, you are actually doing a model rerouting based on the LLM router, and this will diversify the API call on different LLMs. That means your cost is now diversified among like the prompt and other complexity. And then you can just do a standard cost saving on this aspect to understand like what is the percentage we are saving. So we talked about the cost saving, but this is, if you just want to talk about cost saving, you can just pick the lowest cost model and read out all the queries to there. But that is not going to do justice because it may or may not compromise with the user quality. So the other aspect is to make sure that user response performance is still like maintained and it's pretty good. So how do we measure that? One is to have like a quality metrics using a automated Blue Rogue or LLM as a judge. Uh, which is used a lot right now because these are subjective evaluation as compared to like a discriminative evaluations earlier using pre-LLM era. And then having human in loop, like understand like on different rubrics, accuracy, relevance, coherence, like how well we are actually doing, whether you are still maintaining those rubrics in after deploying LLM router and earlier using only one LLM API. Latency, end-to-end measurement of the latency, understand like what is the average latency, P99, P55, P95 and other things, all the systematic aspect on that. Uh, Third one would be the factuality, understanding how often the model is producing incorrect or fabricated information and having some way to do the hallucination index. This is again, you would want to have like a human in loop to make sure this is done correctly. Toxic and I would say like all the policy wise, whether the model is doing really well, it is not producing any toxic output, and it's like doing a very graceful handling of these edge cases and having like where the very tricky and tricky questions are asked to LLMs. How do we make sure that that aspect is still maintained? So by measuring the response performance or the user quality, like these are some dimensions we can look into and probably have our evaluation based on these. Okay, so when we are deploying it, there would be a possibility that, for example, in your system, there is no coding query, and suddenly there is a coding query comes in, and or some other reasoning query comes in, which has not been there in your data set before, like on which you created the preference data set. So how do we make sure like to solve this? So the default way would be to put it to the router, which is more robust and a general purpose, because you do not want to compromise the quality of the user response. Active learning is where you have a new query patterns. You generate the labels for them using agent evaluation or your in-house human labeling team, and then create it into data set, understand and reroute, retrain your model and put it back again. There could be a possibility of a new model. So new model comes into the market and you already have the router deployed with like, let's say 5 models. There is a 6th model come in, which is pretty promising as per the reports and everything, and you want to add it. So if you want to add a new model, first thing would be to understand what is the outside benchmarking performance of those models. I believe if one want to add into the LLM router, that is already vetted. So now the represented data set that you have inside for your specific use case, understand what is the performance coming out like on this, on that data set, and add the inference or the labels on that data set using this new model in. There is another online way where you can have a small percentage of this queries read out to this new model and gather the performance data, loop back in, retrain your model, and then deploy it again. Okay. LLM routings through Databricks component, I believe a lot of you are already familiar with this, the different components. So we will go through like, okay, we talked about a lot of like aspects, how to build it, how to collect the data, train the model, and have the cold start problems. But how do we do this with Databricks components? So on Databricks, we have Mosaic AI, which is the singular most important point for placing your router, because all your queries would be coming in through Mosaic API gateway. That means that's where you need to have your intelligence, where the LLM router is sitting in and understanding what is the prompt complexity and other features, and uh, rerouting it appropriately to the right LLM. This is also where you can do the traffic splitting, like A/B testing, online experimentation, evaluation, and all the logging related to latencies, prompt, what is going in, which model is picked up. All the training data would come up from here. Unity catalog, we talked a lot about like the features, like what are the different features for the prompt, for user, for model that can be put into the model and bake a really intelligent LLM router. So that's where the Unity catalog will come into picture. And also for semantic routing, we would want to have a prompt embedding and a vector databases, which is provided by Databricks. So we can use those components. When we are deploying the LLM router, or when we are doing any kind of experimentation, that's where the ML flow will come into picture, which tracks all the model related experimentation, evaluations, different configuration, artifacts, and traces of the model. And model registry, where we might uh, want to deploy like multiple different routers into the production, different use cases. So that's where you can have all the model like registered there and used for inference. Mosaic AI evaluation framework, and this is there. I think they are like I just attended the talk in the morning where with MLflow 3.0 they are enhancing a lot on the AI agent evaluation, which would be very useful in this particular case. And they are also having the LLM as a judge, which is kind of like a black box sitting. Like you just provide the input prompt configuration, and it can basically just produce the LLM as a judge for your specific evaluation data set and say that, okay, based on these characteristics, please evaluate like this response and provide me some understanding and rubrics based on that. Okay. So this is a little bit like a lot of text there, but let me go through, and this is important because that's where like the end-to-end process of the router flow would happen. The first would be that the request comes in, API gateway receives the prompt from the user, and it forwards that prompt or to the routing agent. So this is the AI agent that is deployed within your Mosaic AI. Once the router received the prompt, it fetches all the features from the catalog and other like feature storing vector databases out there. And then it will put it into the format of how the model is trained and give it to the model. Model will give a response. Okay, based on these features that you have provided, I think the model which is good would be like Llama 8B, the lowest cost, and it would do pretty well on the prompt that is provided. So now once that classification has been done, it's Llama 3B model that you would want to use, then it will be putting it back to the API gateway. API gateway knows what exactly are the endpoint for each of the models which are deployed in the LLM router. And then it will call that particular model API to get a response back. So now you see like how just like the, okay, let's talk about the architecture. If you do not have a routing agent, it goes to API gateway. API gateway will call the default LLM, and you will be inferring all the cost of that LLM and whatever is the response quality. But now you are intelligently rerouting your uh, LLM APIs and which one to use, how to optimize the cost, and still maintain the user performance. So this is something where a lot of your cost reduction would happen, and you can smartly understand and say that, okay, which LLM to use for which particular purpose. Okay, and then this is how like the end-to-end flow would happen at a high level. So the training data which we talked about earlier, like all the payload logging, the API gateway would contain a lot of information. What is going into the system, what is going out back to the response to the user, everything is logged in through the API gateway. So you can have the user ID, what is the prompt, what is the response, which model was selected through the API router, and the latency and other related things. And this is something which is useful for your training. And then all the usage-based matrices, or what is the cost of input output, which is usually static, but it keeps on changing. So those catalogs information would be present in the Unity catalog, and user feedback, positive, negative things, which is logged back into the Databricks system. And then you can use the Spark ML to join all the things, because here you have all the feature, the input output model, latency, and other static features like what is the input output cost for that model, and explicit and implicit feedback. So this is all the data set like can be converted into a training format, normalized, scaled to make sure that you can retrain your model and router again based on that. For the feature engineering, we talked like there are different features from the prompt, users, and model we can use. This is just more like what are the different Databricks components you can use, gateway logs, Spark, the client API. For example, for the prompt embedding, you can use open source, closed source, Databricks in-house, and different kind of prompt like embedding models, and you don't know which one is good and which one is bad for you. So there are a lot of experimentation that can be done on this part, and Databricks does provide the client API, so directly callable from there. Okay, and on the model feature side, most of the features would be present in the pre-processing using Spark and then the catalog. So yeah, on the semantic classification, what we talked about is that like you can have the open source or any kind of models deployed on the model serving to convert the incoming queries into the vector embedding, and this is something you can use for semantic classification and finding what are the similar queries that has been served and which is the chosen LLM router model for that. Vector search, we are already talked about this. So yeah, clustering, offline clustering using the logs and Spark ML. And in online semantic routing, whenever new query comes in, generates an embedding based on the model which we already using. Have the vector search databases to find similar queries and find the best LLM for that. So for evaluation, like traffic and splitting can be done by API gateway, log collection, and analyzing different matrices using different ML component and using ML flow to track different experimentation down there. How do we measure the cost and performance? Like we talked about it like in a technical manner, but here you can build dashboards and other things over to API gateway logs and cost table that is there in the Unity catalog, and get as much insights, have your custom dashboards and other out there. From the quality scores point of view, like LLM is a judge using agent evaluation in the Mosaic AI, and based on that, you can get like different quality scores and what is the ROI based on your custom or use case specific matrices. We are also there in booth 121. So feel free to drop by at a meta booth, and yeah. So this is it. Thank you very much.